Hello everybody. The question 10 again goes into one in a tangent, so apologies for that, but I've done it anyway. The first part just wants you to find dy by dx and leave it in a specific form. So you've got clearly going to use the product rule here, the quotient rule. Specify u and v, differentiate u, differentiate v. Both of those require the use of the chain rule, but hopefully you're getting quite good at that now, and you realise that, say for example, e to the is just going to be e to the times the function times the derivative of the function inside, which would just be 2. So you might quickly have just thought, right, well that's e to the 2x times the 2. Similarly here, x minus 2 all to the power of 2 is going to be 2 times the function inside with the reduced power of 1, and then times by the derivative of the function inside, but in this instance it's just 1 anyway, so that just stays as it is. Then it's about putting it into the formula and substituting in the correct, factorising it in the appropriate way so that it looks like their answer, or like their answer needs to be. So here we've got a common factor of 2e to the 2x, so that can come out first. Then we're looking at the brackets. The maximum amount of x minus 2 we have is just 1, because we've got 2 and 1, so we'll take this factor out here. And then it's what do we times that by to get back to what we need here, and for this term it would be 1 more lot of x minus 2. For this it would just be minus 1, because we've taken all of that out as a factor. And then the bottom simplifies to x minus 2 all to the power of 4, should be another bracket there actually. And then you should be able to tidy it up there, so it's just sorting that bracket out there and cancelling a factor of x minus 2 from the top and the bottom. So you can always look to how the answer is meant to look for clues as well, so that's quite useful. And then yes, specify what a, b and c are. Here's slightly different. They don't give you the full point, but it's a straight line, so we're going to need a point and the gradient. So we've got the x coordinate of the point, so start off by putting the, that value of x into the original function to get the corresponding y value, and there's our point. Then subbing in x equals 1 into dy by dx and simplifying carefully, keeping it exact. Okay, there'll be no marks here for decimalised answers that are rounded. So you've got to be good at tidying up and keeping things exact. And then it just gets subbed into this, and it may or may not specify, so this may have been okay for this question, but you want to be able to be confident doing that as well. Y equals mx add c with exact values of m and c. Okie doke.